Hello students and welcome to my channel Maths Hub. So today we will be discussing about the solutions of linear differential equations and in particular the Bernoulli's equation. So in my last video I talked about the Leibniz linear differential equation. Now let us understand what is a Bernoulli's linear differential equation. So a general Bernoulli's linear differential equation is of the type dy by dx plus px into y is equal to qx into y to the power n. So if you have seen my last video, you will find that this term y to the power n was missing in Leibniz differential equation, right? So now, if this power n is equal to 0, that means it will get reduced to a Leibniz linear differential equation form, and p and q, they are functions of x, right? So how do we solve it? We will try to convert Bernoulli's equation into a Leibniz linear differential equation by dividing by this term y to the power n. So when we divide by the term y to the power n, the middle term will contain the term y to the power 1 minus z, right? And we will put that term equal to some z. We'll substitute that. And when we substitute it, we know that we have to change our differential coefficient. And we change the differential coefficient and we will see that the Bernoulli's equation gets reduced to a Leibniz linear differential equation, right? So let us try to see some examples. So you can see here, the first question is y dash plus xy is equal to x into y cube. So let us compare it with the standard equation dy by dx plus p into x, p a function of x into y is q a function of x into y to the power n. So when you compare the terms from this equation, standard equation with the given equation, you will find that px is x and q of x is x. Both are x, right? So first of all, let us convert this into a Leibniz form. So we divide it by y cube. When you divide it by y cube, we'll get y to the power minus 3 into y dash. 1 power of x will get cancelled. X into y to the power minus 2 is equal to x, right? Now, whatever term we have with the coefficient of x here, substitute that equal to some u, right? Now, the differential coefficient was dy by dx when we are putting it equal to u. So, let us convert it in terms of du by dx. So, let's take the derivative. So, we get minus 2 y to the power minus 3 dy by dx, which is y dash, is equal to du by dx. So let's substitute it back in the given equation. So we will find that y to the power minus 3 into y dash will become minus half du by dx. So this is minus half du by dx plus x into y to the power minus 2 is u, that is equal to x. So if it is a Leibniz equation, we know that we have to make the coefficient free from all the constants and any other term. So let's multiply the entire equation with minus 2. So you have du by dx minus 2 into x into u is equal to minus 2x, right? So now again, when we compare it with the given equation, so here the role of y is being played by u now, right? So here in this equation, what is p of x? P of x is minus 2x. And what is q of x? Q of x is also equal to minus 2x. So let's calculate the integrating factor first. So integrating factor is e raised to power integration px dx, which is minus 2x dx. So this is e raised to power minus 2 into x square by 2. 2 gets cancelled and we get integration e to the power minus x square. So what is the solution? So the solution is u into the integrating factor, that is e to the power minus x square, is equal to integration right hand side function q is minus 2x into e to the power minus x square dx plus constant c. How to solve this integration now? So let's put minus x square equal to z. So minus 2x dx will be equal to dz, right? So from here we get u into e to the power minus x square is equal to integration. Now minus 2x is dx is becoming dz, and e to the power, this term will become e to the power z dz plus c. So that is e to the power z plus c. So let's substitute. What is z? Z is e to the power minus x square plus c. So finally, let us substitute divide by e to the power minus x square. So we get u is equal to 1 plus c into e to the power x square. Right? We are dividing by e to the power x square. Now, u means substitute back the value of u. So u was y to the power minus 2. So y to the power minus 2 is 1 plus c into e to the power x square. Right? So that becomes our final answer. So I hope you understood. So there are basically two steps. First of all is converting the equation from Bernoulli's to a Leibniz form, and then how to put the Leibniz equation, right? Okay, let's try to solve another question. So we have dy by dx plus y tan x is equal to y cube secant x. So the first step is dividing by y cube. So we get y to the power minus 3 dy by dx plus divide by y cube. So 1y will get cancelled and you'll get y to the power minus 2 into tan x is equal to secant x, right? So now let us substitute y to the power minus 2 as, say, z, right? Okay. So we will get minus 2 y to the power minus 3 dy by dx is equal to dz by dx. So the first term will become minus half dz by dx plus y to the power minus 2 will become z into tan x is equal to, right? So multiply with minus 2 on all sides. So dz by dx minus 2 tan x into z is equal to minus 2 into secant x. So you can see that this is a Leibniz equation now. So when you compare it with the original Leibniz equation, your px is minus 2 tan x and qx is minus 2 secant x, right? So your integrating factor becomes e raised to power integration minus 2 tan x is sin x by cos x, right? And we can clearly see that this is e raised to power 2. Cos x derivative is minus sin x, so I can write this as 2 log cos x. So that turns out to be e raised to power cos log cos x square. So it is basically cos square x, right? So now what is your solution then? The solution is z into cos square x is equal to integration. Right hand side function is minus 2 secant x into cos square x dx plus constant c. So minus 2 secant x will become minus 2 by cos x. 1 cos will get cancelled. And we have minus 2 integration cos x is sin x plus c, right? So what is finally z? Divide by cos square x. So 2 sin x by cos square x, it will turn out to be 2 tan x into secant x. And c by cos square x will become 2 secant square x, right? And finally, substitute back the value of y to the power z. So substitute z. So z becomes y to the power minus 2 is minus 2 tan x into secant x plus c secant square x. So this is our final answer, right? Okay. So you can try these problems. So these are the practice problems. So do write your answers in the comment section whether you have understood these problems, and if there is any difficulty in these questions, do write me the question number so that I can provide you that particular question, right? And if you like the video, do hit the like button, and those of you who haven't subscribed my channel yet, do subscribe my channel and believe in yourself and you will be able to succeed. Thank you so much.